So let's begin. I'm gonna grab the book. So let me try and be as reasonable as I can in terms of how we do this. Let me open up the whiteboard here. Give it a second. Maybe it'll load, maybe it won't. I think we're good here. I think the one I'm using is this one, so. How you doing? No, you haven't. Tell me what's the progress.
Just like pistons are fucked.
So you need new pistons.
Yeah. So, okay.
What about the connecting rods?
I don't know. That's all the dude told me.
So, but the pistons are not so bad.
They're just gonna bore out the pistons.
30 over.
Maybe I think he told me.
Okay, so then 20. Okay.
So it's gonna be at 5.5.
Okay, good. So 5.5 liters. The connecting rods were good.
Everything's new.
And the heads were fine?
No, the heads were
Completely warped, but were they warped or he could?
everything's gonna be good.
But your heads, he's just gonna just redo them, right? You're good. Take care of it. Take care of the truck.
I mean, we're gonna road trip.
Then take care of it, and you gotta break in the engine first, nice and easy. Good. Enjoy. Are you going with your dad? Are you
Yeah, after someone that knows something about cars, that's gonna do a load. He's gonna break down midway, 4 hours away.
Good. Good. All right, man. Take care. Show me pictures. All right, wonderful people. So if you started on page 53, and I guess I'll go with orange. Page 53, wherever it starts writing, it has to be over in the corner. Okay, so let's begin with number 2. And hopefully by the time I'm done, you should be able to do this. So page 53, it says problem number 2. And it says find the standard deviation, use the this formula. Please pay attention because some of you do not know how to do this. So this is a formula they give, and they give you some numbers here. 2, 1, they squeeze in a decimal there, 5.3. Yes, I'm recording. -4.2, 6.7, and 3.1. So we have some numbers there, and you have to decide what method you're going to use. There's not a lot of numbers, but again, it really is up to you. So what method do you want me to use? Okay, I mean, or we can use the 2 methods on the same problem. So that way I'm not doing 2 separate problems, which wouldn't matter. It's about the same work, but so let's go ahead and begin with the first thing. So the first method was, let's use a table. First method is a table. And the first thing you do is you have to find your mean. So the mean is going to equal the sum of x divided by n. So we have 1, 2, 3, 4, 5, 6 numbers here. And then you're just going to add 2 plus 1 plus 5.3 minus 4.2 plus 6.7 plus 3.1. Take all that and divide by 6. And supposedly, so this comes out to 13.9. This is approximately 2.32. Now, you should have, I mean, you can use 2.3, but for some reason it feels like that might be too much of a rounding. What happens is, what you should do is you should keep this in memory in your calculator. That way it's more accurate. That's what I would do. In other words, I would keep the actual 2.3166666 forever. It looks like it's going to be forever. I would keep that in my calculator. And so now you would write your x's 2, 1, 5.3, -4.2, 6.7, and 3.1. And then you do x. No need, because we're not going to figure out the median here. We're not figuring out the median. So now we do x minus x bar. And since you kept it in memory in the calculator, I mean, on your table here, you might write it rounded, but for calculation purposes, you're going to use whatever's on your calculator. So this here, -0.316. I mean, if you want to do that, then you put the little line over it. And then you do 1 minus this. This -1.316, 5.3 minus, and you get this 2.983, and -4.2 minus, and you're doing minus this here, and that's -6.516, and 6.7 minus, and then you do it all the way over here. And that's 4.383, and 3.1 minus, and here it is. That's 0.783. And so now we square them. So when you square a negative number, be careful, because sometimes the calculator doesn't realize that you want to just multiply both negative numbers. It just thinks there's a negative sign in front, means to negate it. And when you square a negative number, it has to come out positive. There's no way around it. So when I square this, it's 0.100278. I'm going to keep it in memory in the calculator, of course. So, and every time I'm doing this, unfortunately, I have to scroll up in my calculator. It's a little bit cumbersome, but it's what I got to do to try and keep the accuracy so it doesn't change so much my answer at the end. And most of the time it doesn't. Even if you round, it's pretty close. But we just want to be consistent. So here we go. Now this is rounded when I'm writing here, because my calculator's rounding it already. So let me go ahead and do the next one, 2.9. And then raise that to the second. That's 8.90028. Parentheses. Now I gotta find the -6.5 something. I'm in parentheses. I'm gonna square it. And then now at 42.4669. And then parentheses. This, and then close, and then square it. And we got 19.2136. And then the last one, this one is that, but squared. And we got 0.613611. And then now you add all these numbers up together. So down here, you get the sum of this, all right, squared. And you just add them carefully. Just don't miss any one of them. And what the result of this will be called your variance. So I'm going ahead and adding that whole column there. This will be called our sum of squares. Sum of squared. And voila. It comes out to 73.0283. These are our sum of squares. Now, in order to get our variance, we take our sum of squares and we divide it by, in this case, by n. So it's going to be 6. So we take 73.0283 divided by 6. Now, again, I'm keeping this in memory in my calculator, so I'm getting the most accurate result, even though the calculator is still rounding. And then so sigma is just going to equal the square root of our variance, which is equal to the square root of, or approximately equal to the square root of 12.1714, which is approximately, now I just square root that. And now I could just, I guess, 3.49, approximately 3.49. And that's how you do it. Now, let me make sure I didn't make a mistake. I'm gonna check my answer at the back of the book. Make sure you guys have good notes. And it's really cold in this room today. I did bring a sweater, but I'm trying to see if I can handle it. So they report as 3.489, 3.49, it's fine. So now we do have a shortcut or a formula that makes it a little bit easier. We'll go do that in orange here. So the formula for that is we have the variance equals the sum of x squared minus the mean squared. But I believe it's like this, okay? That's very important, okay? So I think I derived this for you last time. And so what you need to do is you need three things. You need to know n, which you do, which is 6. You need to know your mean, which we do. But unfortunately, we have a rounded version of it. So what you should do for your mean is you should just keep it like this. You should say it's this. Because for calculation purposes, we don't want to use 2.32. We want to use 13.9 divided by 6. And now what we do need is we need the sum of x squared, which essentially is just 2 squared plus 1 squared plus 5.3 squared plus negative 4.2 squared plus 6.7 squared and plus 3.1 squared. So we have to go through the trouble and do that. So it's 4 plus 1 plus 5.3 raised to the second plus parentheses negative 4.2 close the parentheses raised to the second plus 6.7 raised to the second plus 3.1 raised to the second. And so we get 105.23. So now we have everything. So your variance is going to equal 105.23, but divided by 6 minus parentheses 13.9 divided by 6 squared. So I'm going to go ahead and get my number for that. So I'm going to take parentheses 105.23 divided by 6, close the parentheses, minus parentheses 13.9 divided by 6, but I'm going to go ahead and square this. And I get this equals 12.1714, which is the same as that. And when I take the square root of that, it's going to have to give me the same thing. And as you notice, there's advantages to doing it this way versus the other way. But in general, that's how we do it. Okay, does that make sense? Again, guys, you have to study in order to do well in the upcoming tests and quizzes, because it will be comprehensive. I'll make sure that I address each one of these. All right, so I'm assuming that that's not the only one that you had trouble with. That you had trouble with number 3. Go. There's no dumb. Yeah, well, go ahead first.
Where did you get the N?
Well, how many numbers do we have?
Oh, okay, hold on. You realize I don't remember.
It's not a dumb question. A little bit dumb. Okay.
Wait, hold on. And then we're doing the 13.9. So then you add them all up. They're 13.9.
Yes.
Okay.
And then I divided it by 6. I kept it that way because I didn't want to use a rounded figure. Because I could have used 2.32, but that's a rounded figure of 13.9 divided by 6. Even though the calculator is rounding too. but it's just more accurate.
So on the quiz,
Be sophisticated. Try to have this level. It's not a very high level, by the way, but this level of sophistication to where you understand that you're using technology to help you get a more accurate answer. You're not rounding early. You round at the end.
okay. Can I use one method or do I have to?
Do you use whatever method you like?
Okay, so there's not gonna be a question mark using this method.
No. But there might be a question where you have to use a particular method because there's no other way around it. Because I don't give you the original numbers, for example. Yes,
Okay, you say hi.
be careful. Yes.
Hi.
Hello, Shayla.
So like, I'm here.
I know, but
I'm late.
I can't do anything about it because
I
you
know,
weren't in
I'm just
class.
letting you know.
But I'm glad you're here.
Okay, bye, mister.
Bye, Mama.
You're so weird. It's like, hi, I'm here.
All right, so let's scroll up. Yes. Only be careful. It's kind of cold, guys. Let me go ahead and just. I know. I guess it started.
I don't think I've ever been so weird. Because no, I feel like it's gonna be cold outside.
All right, so let's continue.
How cold outside? 23. Yeah.
All right, wonderful people. So let's go to the next question. Number 3. Do you want me to do number 3?
Okay, wait, I have a question.
Go ahead.
Can you do a problem where like you're like, oh, this problem you might have a specific method? Can you show me a problem? that you
Number
can-
3.
Is that what the
Okay,
test
then
is
use
gonna
that
be
one.
like?
Huh?
Is that what the test is gonna happen, like meeting and then the histogram?
Yeah, well, what you could expect on a test is you can expect me to try and make you do a mean, make you do a graph. It could be a histogram, it could be cumulative frequency, it could be a stem and leaf plot.
Okay, the middle one you said.
It could be, yeah, of course, yeah,
No. What was the middle one you said?
cumulative frequency.
That's the chart.
I'll try to go over it today. If I don't feel like today's review was enough, I'll delay it to Friday. I just want to make sure.
Yeah, it was on Friday. You said it on Tuesday.
Okay, so that means okay, I felt that maybe I couldn't cover everything I need to cover today.
Okay.
So, Mr., all of this will be on the test.
Yeah, you can expect mean, median, mode, a cumulative frequency graphs, histograms, stem and leaf.
How many questions is this quiz?
So it's gonna be a few questions, but I'm gonna make sure that some of them are right to the point, that are quick, and some of them could take a little bit longer. Yes.
Will there be like a sample on Teams that we can practice and do multiple times?
Well, that's what I'm gonna be reviewing today. So whatever I put on Teams is what I plan on reviewing, using for review. Yeah. All right, so don't stress, guys. It's just, try your best. All right, let's look at number 3. This is on page 53. Now, there it tells us, so this is number 3. You know what I'm gonna do it in purple?
Oh my God.
Hello.
Class has a Valentine's Day.
Okay, go ahead.
Yeah.
Oh. Okay. Hey.
That's a big. Oh my God.
All right. That's wonderful. Enjoy, guys.
Okay, but that's like funny thing is like, wait, what? I don't know. That she said that one of them was singing to the guy that was singing, is dating his sister. So the sister got it for him and he's doing this. I was really.
I had no idea what song it was until
I wish they come to like everything.
I still can't, it sounds so familiar, but I still can't.
I'm so shocked that it's not but they are.
All right, wonderful people. Let's settle down. That was good. All right, number 3 says the mass of X grams of 25 tins of brand A, it's anchovies, are anchovies. I just didn't write that. It says are summarized by the sum of X equals 1,268.2 and the sum of X squared equals 64,585.16. Then it says first find the mean. Then it says what is the unit measurement of the variance? So this question, for instance, is a question you're forced to use certain formulas to solve. You can't use a table because you don't have access to the original data. You've had summaries of it. So now you're forced, because of this question, to use that shortcut we were talking about. But let's first find the mean. So the mean is very simple. It's just going to be the sum of X divided by N. Do you know what N is here? 25. So it's just going to be 1,268.2 divided by 25. And so I'm going to go ahead and write that. So now I want you to understand that this is grams, okay? So the result you're going to get here is going to be grams. Whatever I write now is grams. So I get 50.728 grams. That's the mean. Now, the variance is going to equal to the sum of X squared divided by N minus the mean squared. Okay, that's what we did in the previous problem. So we're going to go ahead and write it. Now, I'm going to emphasize the units here. The units are going to be emphasized. So if I square each of my numbers, then this here should be 64,585.16, but this should be grams squared. So imagine you add the first number, you square the first number, you're also squaring grams. And you're going to divide this by 25. And you're subtracting here 50.728, and you raise that to the second. Now I gotta be careful here. I want to emphasize this notion about the units. I gotta switch between purple and red. All right. So when I do this math, so I'm gonna go ahead and do it in the calculator. 64,585.16. Divide that by 25. And then we're going to subtract 50.728. And I miswrote that there. 50.728 raised to the second. And that gives me that my variance, I'm never going to switch colors again like that. My variance is 10.0764. Now notice it's grams squared. Now when I square root that, square root of 10.0764 grams squared, the square root of this it's gonna be approximately 3.174, and like the grams are just grams now. You see it? Because the square is canceled, I guess you could say, by the square root. And so what are the units for standard deviation? Well, the units for standard deviation is the original units. So on average, the data is 3.174 grams away from the mean. Spread out from the mean away on average. And make sure I didn't make a mistake and giving you good notes. Section 3, I think this is 3A or 3B, I'm not sure. What question is this? This is okay, there it is. So we're fine. Notice, I guess they asked here for the variance. For the variance, notice it was gram squared. But notice that for the standard deviation, it went back to grams. Okay. So do you see why you need to know both of them? All right, let's go to number 4. So number 4 says the standard deviation of 10 values of variable is 2.8. So it says the standard deviation for 10 values of a variable is 2.8. Now, my advice to you is that you try these problems on your own, especially if you didn't do your homework. You try it on your own, you look at the video if necessary, but you try it on your own. Then it says there, the sum of the squares, so the sum of the squares of the 10 values is 92.8. Find the mean of the 10 values. So what you need to do first is you need to decipher this from the writing in words, and you write it out mathematically. So it says there's a standard deviation. So they actually tell you straight up that the standard deviation, I shouldn't be using sigma, I should be using S. This book likes S. So S. Yeah, but in ACE, they're not making that distinction. It's a small distinction, but it's also, I should have been using S just to be consistent. So I'm going to go ahead and erase all my sigmas. All right. So standard deviation for 10 values of variable is 2.8. So we can already write S is 2.8. So the sum of squares, of 10 values is 92.8. So we add them all up and it should be 92.8. By the way, N is 10. Now it says find the mean. Find the mean. So we can say S squared equals the sum of X squared divided by N minus X bar, but squared. Now, you could just go ahead and substitute in here. Or if you rearrange this, it's up to you. Like if I rearrange this right now, I would write X bar squared equals the sum of X squared over N minus S squared. Therefore, X bar must equal the square root of the sum of X squared divided by N minus S squared. You could do that. And that means that you have that the square root of 92.8, which is already, that's the sum of X squared, divided by 10 minus, well, we need the mean. We can't do it without the mean. So I had to find the mean. So let's do that first. Oh, well, that's what I'm trying to do though. By s squared. What's s squared? 2.8 squared. There we go. We found the mean. So we have 92.8 divided by 10 minus 2.8, but raised to the second. I get that this is 1.44 when I do the math. And when I square root that answer, I get equals to 1.2. So now I know my x bar is 1.2. And you're done. I checked it. Are you sure? For what? For x bar. Yeah, I know. There's two parts to it. 50.728, no? For the mean, yeah. There's two parts to it, so, but thank you. Okay. Good. No, it's okay. No worries. As long as, you know, if it's wrong, I'll fix it, but I checked it, I think. I don't want to give you guys bad notes. All right, so let's continue. Number 5. So basically, I'm doing your homework for you. You guys gotta get in the habit of doing the best you can to do your homework as much as you can. Yes. Huh? Yeah, don't worry about it. I didn't collect it, but you're checking it now, or is it? Were you able to do it? See, look, we have surface. Her surface is bigger than mine.
Are you jealous?
Look, she's cool like me. Does any of your teachers use this?
No, no.
Why not?
Because it's really expensive and hard to type. Some teachers, like my mother, are struggling to use that by itself. I don't think she should get a Surface Pro and try to figure it out.
She could do it. All right, number 5. The mean and the standard deviation of the height of boys in a class are 148.8. So we have 12 boys, and their mean height is 148.8. And the standard deviation, I'm sorry, SD, is 5.4 respectively. This is, now we're gonna add a boy of height 153.4 joins the class. So some kid shows up and his height is 153.4 centimeters. Now you need to find the new mean. So find the new mean and SD for the class. Basically, that's what the question is about. And so here's what I would do. I would just say, okay, x bar equals the sum of x divided by n. So originally, the mean height was 148.8, and it equal to the sum of x divided by 12. That's what I would have. And now indirectly, you could find right there, you can find that the sum of x equals 148.8 times 12. So 148.8 times 12, 1,785.6. Okay. Now, the next part to it is I say that S equals, and I guess in this case, I have to be somewhat careful. I'm just going to write S equals, I don't know if I should use this formula. I don't think so, because I think it's going to be cumbersome to use, but let's give it a shot anyways. All right, so S equals the square root of x minus x bar squared. you know what? Let's use this one better. The sum of x squared divided by n minus x bar. This one's gonna probably be better because we're gonna be able to figure out the sum of x squared there. So if I put 5.4 equals the sum of x squared, which I don't know, divided by 12 minus the mean. And the mean was given to me as 148.8 squared. I can use this now to solve for sum of x squared. Like sum of x squared is gonna equal 5.12 times 5.4 plus 148.8 squared. I mean, you should see how I rearranged that, right? You see it? You see what I did there? If you have 5.4 equals sum of x squared divided by 12 minus 148.8 squared, the first thing you would do is you add the 148.8 squared to the other side. And then you're left with this. And then you're just going to go ahead and multiply it 12. Now, of course, you have to put the parentheses around that other side. All right. So now you just calculate that. It's going to be 5.4 plus 148.8 raised to the second. You're going to multiply that by 12. And you get that the sum of x squared has to equal to some big number here, which is 265,762.08. Now, for the sum of x for the first 12 boys is equal to 1,756.6. First 12 boys. Now, with the 13 boys, we're going to have to add his height. His height is 153.4. So I have to take 1,085.6 plus the 153.4 centimeter of the new boy. So that's 1,785.6 plus 153.4. And so we have 1,939. So this is now the new sum of x for the 13 boys. As a consequence, now you can compute the mean, the new mean, because you would take, so as a consequence, you can now compute the new mean for the 13 boys, because the new mean will just be the sum of x divided by n. So it's 1,939, but now divided by 13. So divide that by 13. And the new mean is 149.154. But it goes on forever, so I'm gonna keep it in the memory of the calculator. I don't know if it goes on forever, but you could do that for reporting purposes. But now guess what? So here's the new mean, right? Now they also want us to find the standard deviation. So what you need to realize is that the sum of x squared equals 265,762.08 for the first 12 boys. But now the sum of x squared must equal 265,762.08 plus the new boy's height squared. You see that? So you have 267 something thousand. Sorry, 265,000. Let me erase this answer here. Okay. And you're going to add now 153.4, but squared. And so now you have that the sum of x squared must equal 289,293.64. This is now the new sum of x squared of the 13 boys. But what does that allow you to do? Well, that allows you to use this formula here, right? To find the variance, and then take the square root of that to find our standard deviation. So S squared must equal 289,293.64. Divide that by 13 minus, and I'm just gonna write it like this, the mean. Now you should have kept it in memory in your calculator, and then you square root that. So I kept it in memory. There I have it. Divide that by 13, then put it in parentheses. I'm gonna do it all in one shot. Okay, there's a parentheses, minus parentheses. I'll put 1,939, divide that by 13, close the parentheses, square it. And it tells me that my variance is 6.4871. I'm sure it's a bigger number, it's rounded there. But now I take the square root, it's in memory in my calculator. And the square root of that, so S equals the square root of 6.4871. I should just say approximately here, because that is rounded. And I'll just go ahead and round this to 2.54567. And that's how you do that problem. Let me make sure I did it right, didn't make a mistake. And that's how you do it, bro. So let's see. And this is number, yeah. Wait, this is number 5. All right, so I got the mean correct, but it seems that my standard deviation is off. My standard deviation should be 5.33, and I got the bigger number. So now I gotta figure out my mistake. So that doesn't make me happy. Oh well. So what? Oh wait. So the mean is correct, but let's see where I went wrong on my standard deviation. Oh, I have an original height, 5.4. So we gotta go up. We gotta start now up top. You got 5.34. Okay, so let me just see where my mistake is here. So is my mistake at the beginning or towards the end? So I'm gonna go through it as quickly as I can so we don't waste too much class time. I take 5.4, I add 148.8 but squared, right? And then I multiply that by 12 and I get 265,762.08. Fine, that's the sum of x squared. If I take the sum of x squared and I add 153.4 but squared, 153.4 but squared, I get 289. There it is. No, there, I did it right. All right, so let's let me see. 289,293.64. Okay, fine. So now we take that and divide it by 13. Yes. No, I'm just talking to myself because I'm trying to see where the mistake was. Sorry. And then I go ahead and do 1,939, divide that by 13, but square it, and I get 6.48. So I keep on getting the wrong answer. 2.54 is what I'm getting. And the book is 5.33, right? The book says 5.33. Lovely. All right, did I write the standard deviation right? Ah, I see. Guys, here's the problem. Here's the problem. Yeah, this has to be squared there. The problem started right here. All right, so now I have to redo this, just change these numbers around. Because this is This is the variance, not the standard deviation. Very, very important. 5.4 raised to the second. I add 148.8 but squared. Multiply it by 12. Now I get a different number. It's a slightly different number, but it's enough. I'm up there, you see? This would be 5.4 squared. So it's enough that it will make it, that little small difference is enough. So now this changes to this. 266,047.2. And now we're gonna add 2,6. Oh my gosh, look what it did. So let me fix that right there. 266,047.2. I'm gonna add 153.4, but raise to the second. So now it comes out to 289,579. Could it be that much of a difference? Feels like it's not gonna be, but maybe I'm wrong. Right? And then now you're gonna divide this new number. It's not a substantial difference. It's very small, but I'm gonna divide that by 13. I'm gonna go ahead and subtract parentheses 1,939 divided by 13 squared. And that comes out to, wow, that's incredible, huh? What a big difference. And so now it's correct. When I square root that. So it's approximately 5.33. There we go. Oh, okay. So let's continue to the next one. And then I want to go ahead and extend this to the next few. So we have here, thank you. We have here the runs made by two batsmen, Anwar and Kazim, in 12 innings during 1999 cricket season are shown in the following table. So we have Anwar and we have Kazim. I'm assuming that's how you say it. Two people. And we have some numbers here. We have 23, 83, 40. We have 0, 89, 98, 71, 31, 102, 48, 15, and 18. And then we have 43, 32, 61, 75, 68. Let me make sure I at least write them together. 92, 17, 15, 25, 43, 86, and 12. So they're asking us, give your reason, state which batsman you consider to be better. So who's better? And then who's more consistent? And like, okay, so who makes more runs? Usually that's what it means. It's not always, but here's what you're supposed to do. So you're supposed to find the mean and the standard deviation for each. All right, now I think I want to cheat because I don't feel like doing the standard deviation for each one of these. So I'm going to probability, no, statistics. Huh? A stat calculation, one variable stat. Okay. And this one. Okay, so let me go to my list here. You know what? I don't know how to do in this calculator. Incredible. So where's my list? Let me escape this. Escape this. I don't know how to do the me on my calculator, this on my on this TI Inspire, and I'll do a TI-84. My mother called me. I wonder what she wants. Yeah, no, but I'll call her. Usually she misdials. So calculator. All right, so I'm gonna go ahead and put this on my all right, the way they want you to do this, I'll be honest with you, is they want you to they want you to find a mean and standard deviation for each. A surface? What happened to your, what just happened to it? It just broke like that?
It didn't even fall though, right?
No.
Just small fractures.
Okay, but
Oh.
It's been there for like a year and nothing's ever happened.
And so now it just,
I didn't know that.
well, I mean, those MacBook Airs, maybe you can get it fixed, but I'm sorry. All right, so here's what I'm gonna do. I'm gonna use an online calculator. So mean and standard deviation calculator. So I'm gonna put these numbers quickly on here so we can just, because right, this is a conceptual question. I mean, it's both. I mean, it wants you to practice a calculation, but it's so boring to calculate right now. So you come here, let's say, and you put the numbers 23, comma 83, comma 40, comma 0, comma 89, comma 98, comma 71, comma 31, comma 102, comma 48, comma 15, comma 18. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got all the numbers. And so I'm gonna go ahead and say sample. No, I'm gonna keep it population because yeah, and then it'll mess it up. So for Anwar, we have that the mean is 51.4. So these are 51.4 runs, and the standard deviation is 34.1. Okay. So now we're going to do the same calculation, but for Kazim. And so I have to erase these numbers here. And it's 43, comma, 32, comma, 61, comma, 75, comma, 68, comma, 92, comma, 17, comma, 15, comma, 25, comma, 43, comma, 86, comma, and then we have, I think 12, but I wrote it so ugly on my thing that I'm not even sure what I wrote there. So there we go. It looks fine. So let's go ahead and calculate this. And so the mean here for Kazim is 47.4, but the standard deviation is 27.2. So now let's talk about this for a second. So who's the better player? Well, it seems like Anwar scores more runs. Okay. However, Kazim is more consistent. Having a smaller standard deviation means things are, the data is less spread out. So he has, I mean, he's a slightly more consistent player. So it depends. Who do you think is better? Well, I like consistent players. I think consistency is better than people who have like streaks.
Wait, so but for this question, like question A, it would be a dark.
Yeah, if you would say Anwar and you would say, you know, in my view, Anwar is better because he scores on average more runs.
Explain it like a written response.
Yeah, I mean that's what we're expected to do in statistics.
What do you mean?
Now you got to realize that the lower standard deviation is, the more consistent something is. So we really want things that are predictable, and we want players that are predictable. So you, in theory, you want to maximize the average and be consistent. It depends on the situation, because sometimes you don't want consistency. Sometimes a higher average means bad. So it depends on the context of the problem. Okay, so that was part of your homework. Now, I want to go ahead and talk about a second branch of problems of standard deviation, which you haven't done yet, but that I want to go ahead and help you do. And so this will be, I'll just be doing problems from page 57. And I'll go ahead and start with number 1. And basically number 1 has number of absence. You can, this is the, I guess you could say this is the random variable, absences. And you have 0, 1, 2, 3, 4, and 5. And then you have a number of days. So that's the frequency. So you have 54, 24, 11, 4, 2, and 1. Okay, so let me fix that. So that's what you got. And they want you to figure out 2 things. They want you to figure out the mean and the standard deviation. Okay, so they want you to figure out the mean and the standard deviation. My ears are still cold. Yeah.
It's like tolerable.
Yeah, he's giving dramatic.
What is wrong with
I
you?
can't
The
handle
day
it.
that it's cold, he's not cold. The days that are not cold, you're cold.
It's cold.
No.
All right, so they want us to find the mean and the variance. I guess I'll do the whole thing. So here's how we do it. So let's do the mean first. So X bar equals, for the mean for this frequency distribution looks like this. All right, it looks like that. So I'm going to go ahead and figure out the sum of F here. That's 54 plus 24 plus 11 plus 4 plus 2 plus 1. So total frequency here is 96. And so X times F will be this column here, which I'm going to make. 54 times 0 is 0, 24 times 1 is 24, 11 times 2 is 22, 4 times 3 is 12, 4 times 2 is 8, 5 happens once. So you could see this as 0 happens 54 times, 1 happens 24 times, 2 happens 11 times, 3 happens 4 times, 4 happens 2 times, 5 happens 5 times. And then you can add all these up. And once you add all these up, you're going to get the sum of all the numbers. Right? So I'm doing it. And so this comes out to 71. And now you take 71 and divide it by 96. And 71 divided by 96, that's some number, 0.739, which actually, I'm just write 0.74. I think that's okay, but we're not done. We had to do the variance, and that's where, and let me make sure I got my mean right, because I might need the mean, and so I don't want to waste time. I am starving. No, this morning I took a protein shake.
I would have thought the more you take like calories and like the faster the calories, the hungrier you get.
Yeah.
No,
I know the 22nd.
Maybe you're colder than all of us.
I worked out this morning early. I did a good workout today. I liked it. Yeah, I'm correct. So now here's the problem. I haven't taught you yet how to do standard deviation for this. So let me show you. It looks something like this. So let's do the variance is the sum of X minus the mean squared times F divided by the sum of F. That's what you have to do. So that's the extension of this. They also have a shortcut to it. They say it's a sum of x squared times f of I divided by the sum of f equals minus this square. Okay. So I guess the best thing to do here is this guy. And I'll put it on the board. All right. So what you're going to do is you're going to take, there's no way around it. There's no way around it. You got to do it. There's no way around it. So I'm going to go ahead and lasso this and pull this to the left a little bit to give us some space. Wait, give me a second. This is not lassoing correctly. Wait, why didn't I do it? Give me 1 second. I'm trying to lasso. All right, there's the box. Perfect. I want this down here. And I want you over here. Okay, so let's see. I'm going to go ahead and figure out. I mean, I have choices to make. I'm going to go ahead and square. There's a few ways to do it. This is the thing. There's a few ways to do it, honestly. You could do it doing x minus. Well, it doesn't matter. I'll create an extra column, but it's not necessary. So you could do x minus the mean now. And then you could do x minus the mean squared. And then let me write it as x bar because this book doesn't use mu. And then you could write it as this here. And that takes care of doing it this way. You see? But you could do it another way. You could go ahead and these are your x's and these are your frequencies, right? You can now do your x squareds and then take your x squared and multiply times your frequency. You could do it either way. And they're both right because this way here will be used over here. You see? So let me go ahead and do it both ways. Let me do it first the red way. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Now you got to multiply times the frequency. 0 times 54 is 0, 1 times 24 is 24, 4 times 11 is 44, 9 times 4 is 36, 4 times 2 is 8. Wait. I'm messing up. 1 times 24, 4 times 11, 9 times 4, 16 times 2 is 32. 25 times 1 is 25. Now I got to add these up. So I got to go the sum of x squared f 0 plus 24 plus 44 plus 36 plus 32 plus 25. That's 161. And so now I can just do this here. I can just come here and say, okay, this equals 161 divided by 96 minus, and I could write 71 divided by 96 squared, and it saves me a little bit of time. So parentheses 161 divided by the sum of f minus parentheses 71 divided by 96, but now squared. And it gives me a fraction, so I'm going to tell it to give me a decimal. So this is approximately 1.13. Now, you could have done it another way. See, you could have taken here's the problem that it gets cumbersome. I don't feel like doing it the other way because there's a lot of rounding here. But you would just take this X here and subtract the mean. Obviously, it would be better if it wasn't rounded and write it here. And you would repeat that over and over again, right? You get all of them and all of them, little by little. You get these. Then you square it. And then you multiply times the frequencies. Then you add it all up here. Right? And then you divide it by 96. And then you square root that. And you get the answer. Now, this is the variance. This is the variance. They didn't want us to find a standard deviation. I think the answer is correct. Now, it is. Oh. So I'll take a look at it. And it is correct. But this is not just the only problem that you need to be able to do. Sometimes you get a group frequency distribution. And so the way you're going to take care of that is, so let's say you have, and I won't even do a problem from the book. I'll just make up one right now. So let's say 0 to 10, 10 to 20, 20 to 30, and 30 to 40. Now, in this case, I think it's very important that the classes have the same class width. If we remember from chapter 1.
Good morning, gladiators, and please excuse this interruption. We will now have a moment of silence to remember those 17 individuals who lost their lives at Marjorie Stoneman Douglas High School 4 years ago. In memory of those who died at Marjorie Stoneman Douglas High School, live a life of meaning and purpose. Let it start today. Thank you.
All right, so there's your classes, there's the frequencies. In this case, you gotta still execute. I can make that so much better. It looks so ugly. Huh?
On your fantastic tablet,
The glitter?
the ruler.
Yeah, I do. Here we go. Ruler. It's just, takes time. Okay, let me do that. Oh, damn. The glitter makes everything more understandable. Okay, so let's do that. Every little bit helps. So here we go. Here the class. And so what happens here is we gotta calculate both our mean and we gotta calculate our variance or standard deviation, right? And remember, this is the original formula to the mean, to the variance, but if you're using the shortcut, quote unquote, you still have to figure out x squared. All right, you're still gonna do that part, but it just makes it a little bit easier. So what you're supposed to do is, here's our problem. What x do we use for the first class? Do you use 0? Do you use 1? I mean, you don't have an x. Like the previous problem, there was a clear X. It was whatever number was there, 0, 1, 2, 3, 4. But here you don't have one. So what should we use? We should use the midpoint. So we just take 0 plus 10 divided by 2, that's 5. And 10 plus 20 is 30 divided by 2, it's 15. And so these right here, these are your X's that you're going to use. These are your X's that you're going to use. And so now you can go ahead and calculate your X times F because you're going to need it. Right? X times F you can calculate here. X squared you can calculate here if you like. X squared times F you can calculate right here. And down here you can get the sum of X squared times F, which you're going to need right there. And you need the sum of X times F because you're going to need it here to calculate your mean. So 5 times 1 is 5, 15 times 2 is 30, 25 times 3 is 75. And lastly, 35 times 4 is 140. So it's 140 plus 75 plus 30 plus 5. So that's 250. And so this is 250 divided by the total, which is the sum of F. 4 plus 3 is 7, plus 2 is 9, plus 1 more is 10. So it's a nice number, 250 divided by 10. Well, that's 25. And so now you can square each of these midpoints. This is 25. This is 225. This is 625. And the last one is 1,225. And then you take 25 times 1, that's 25. 225 times 2, that's 450. 625 times 3, that's 1,875. 1,225 times 4, don't mess this up because it's easy to mess up, 4,900. And if you add all these, right, you get 7,250. So that allows you to take 7,250 divided by 10 minus 25 squared. So 7,250 divide that by 10 minus 25 raised to the second. So S squared is 100. So S equals the square root of 10. And that's how you would do a mean and standard deviation for a group frequency distribution. Okay, so I think that's enough for today. That was quite a bit. Next class, we're going to go ahead and delve deep into the ACE type questions. And your assessment will be available on Friday. You're gonna do it and you're gonna show me what you know. Be careful. All right, so let me go ahead and put this on YouTube. So let me go ahead and go here and. Oh, you saw them?